Hello, hello. Now, title of the today's experiment is modeling and analysis of mechanical system and its simulation and its verification using simulation software. Okay, here in the mechanical system that we are using, that is spring mass damper system, and simulation software that we are using as MATLAB or Octave. Now, for this experiment to solve, there is one numerical is given. Where I will read the statement. A spring mass damper system has the following parameters: stiffness 800, mass 3 kg, coefficient of damping 20 Newton second per meter. Now here this much things we have to find out: transfer function, step response, time constant, x value at force value 12 Newton, and this is the static condition. And next f value we have to find, and when velocity and acceleration are given as 4, 0.5 and 4 meter square respectively. Now this is the formula for the transfer function. As it is spring mass damper system, here you have to remember this formula. Okay, remember students, this is very important formula. Transfer function is equal to 1 upon ms square plus bs plus k. And if you put all these values here, m3, b is equal to 20, and this is 800, then your final answer for the transfer function will be like this. Now next, time constant we have to find out. For the time constant, formula is t square is equal to m by k. Okay, m by k formula is there, and its value is 0.0612 second. Now at static condition, this is the second point we have covered. Point B, this is point A. Now point C. At static condition, uh, acceleration is zero, velocity is zero. Hence, what is the formula that you are looking? Acceleration and velocity become zero. Hence, whatever the force is there, that force. See here, this is nothing but total force is there. This total force is sum of spring force plus force due to mass and force due to coefficient, damping coefficient. But out of these three forces, if this is zero due to the force due to the mass, this acceleration is zero, and here in this case, if velocity is zero, then the whatever the resultant force is there, that is only due to the spring stiffness. Okay, hence force value finally means remains as F is equal to Kx. Okay, and here F is equal to Kx, hence X is equal to 12 upon F upon stiffness. Stiffness is 800, and X we have to find out. Force is given. Force 12 Newton is given in the numerical. That value we have to put here, and you are getting the answer. X is equal to 0.015 meter. Now at dynamic condition, this is was the static condition. Force in this point now we have to solve. Okay, last point. What is the last point? Here in the last point, acceleration is 4 and velocity is equal to 0.5 meters per second. Okay, now here we have to find out force. Force means all the forces we should know this spring force, mass force, and damping force. For spring force, we require to find x, and x can be calculated by using this formula, kinematics uh, kinetics formula. V square is equal to u square plus 2ax. Now at initial condition, initial velocity is 0. Here we can find the v square is equal to twice ax, and put the value of 0.5 here. Then 0.5 square upon twice into 4. Then the x will be 0.031. X will be 0.031. Hence, from By knowing the value of x, you can find out the force, dynamic force, and that is the force, net force acting on the system is nothing but force due to the mass, force due to the damping, and force due to the stiffness. And if you put these values here, the final answer you are getting as 46.8. Okay. Now, now this problem we have to solve by space by considering as state space equation model. In state space equation model, this was the means up till now whatever we have seen, that is the traditional method. Now this part is nothing but here the second part of the experiment we are going to do now from this slide. From this slide onwards, the second part of the experiment we are going to do. What is the second part of the experiment? And its verification using suitable simulation software. Now we are going to do the verification part. This part we have completed. Okay. Okay. Now this type of problem can be solved by using considering the system as state space equation model. In that there are two equations are there, x dash is equal to ax plus bu and y is equal to cx plus du. This is by this is the equations of the state space equation model. Now what is the here x dash? Okay. Now we will see each term one by one here. X dash is equal to if suppose there are uh, second degree equations are there. If second degree equation, then there will you have to take the three terms means three rows in the x column. Okay, x matrix, x dash matrix. Again here three rows. If it is linear equation, then only you have to take the two rows. Okay. Suppose this is there are second degree equation, then the equation given is x second degree, then x dash is equal to for that x dash plus x double dash x triple dash and x is equal to just you have to means now this x dash is nothing but one time derivative, this is two time derivative, this is three time derivative, and in x means the first term will be normal x, second term will be the one time derivative of x, and third term will be the two times derivative of x. Okay, just like you have to remember here in x dash each term consists of dash. In x only first term is x, and second term is single derivative of x, and third term is double derivative of x. Okay. Now what is u? U is equal to f of t. U is equal to f of t. Now next thing you have to do, you have to find the four matrices A, B, C, D. These four matrices you have to find out. Now, what is the uh, rows and column order of matrix A? That is n by n. Order of matrix B, that is n by m. What is the order of matrix M C? M by n. And what is the order of matrix D? That is m by n. Okay. Uh, Now, what is this n by n, m by m, n by m? See here, n by n, n by m, m by n. Here, first n cross m, then m cross n comes, then m cross m. What is this n and m? We will see. Now, see here, the f of t equation that we have given. In that equation, that is n is equal to, see here, what is this f of t equation? See, See here, this is the f of t equation. If you write this equation in the form of time, then f of t, it will become f of t is equal to mass into d2x by dt square. Mass into d2x by dt square. Double derivative of what is acceleration? Acceleration is nothing but what is the acceleration? Let's see, I will write out this. Give it a minute. I will start the equation editor. Just I will copy this statement, Control C and Control S and close, and I will paste here. Okay. Now this statement we will write some. We will write this statement in other way so that I will make it smaller f. F of t mass into d2x by dt square d2x. Wait a minute. Here I have to take one division. Here again I have to take division. Okay. So see here mass into acceleration. Acceleration is nothing but double derivative of x dt square. Okay. Now see here this is the this is again d2x by dt square, and here instead of v we have to write dx by dt dx by dt. Okay. Okay. Control S. Now see here this is the second degree equation, hence n becomes 2. N becomes 2, and here x x is, there is only one input parameter and only one output parameter. This is the input and x is the output. Hence m is equal to 1. Remember n is equal to 2. Why? Because here it is double derivative equation and m is equal to 1. Okay. I will save. Now we will go to the next slide. Hence n is equal to 2 and m is equal to 1. Okay. N is equal to 2 and m is equal to 1. If you write means a will become your a was n by n, but here n is equal to 2, hence a matrix A will become of the order 2 by 2, and similarly matrix B will become of the order 2 by 1, C 1 by 2, D 1 by 1. Okay. In this way we can find out A, B, C, D. Now what are the now order we have found out. Now what should be the terms inside the matrix A, B, C, D? We will see that. For that, just we will do some rearrangement. F of t equation m d2x by dt square, just we have seen bx dash plus kx. Okay, some rearrangement here. Just if you here in this equation we divide each term by m, then this kind of equation becomes. Okay. Now see here this is x double dash is equal to minus b by m x dash minus k by m. Here x will come. I will make it correction. Yes, I will make a correction here. Here the term x will come. Here the x term is here. X. Okay. Now it's okay. Now if you put the values of that uh, k, m, and b here, that x double dash will become like this: x minus 20 by 3 x dash 800 by 3 x. Again, I forgot here x. I forgot to write x. Okay, let us suppose here x is there. Okay, it is taking time. We don't have that. Now we have to find. We have to complete this equation. State space equation model. X dash is equal to ax plus b. Bu was there. or instead of u we have written b of f of t. Okay. Now x dash is not as we it is what is x dash, as there are only second degree equations means only two terms will come and it is a column matrix. Okay. Yes, x first term will be x dash and here it will be x double dash. Now see here, x double dash equation is this. If you want to write down this equation here and in the matrix form, you have to just take, you should know some matrix multiplication formula. Now see here, as A is equal to 2 by 2 matrix, just keep here dash 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 dash, and here x is nothing but x dash plus dash dash. Suppose here no term is there and f of t. Initially suppose here no term is there. Now we have to bring the statements, means we have to complete this now matrix. How we can complete? See here, first of all you see the equation of x double dash, and in equation of x double dash, see you are going to multiply the matrices. How you are going to do the multiplication? How? See here, always row and column multiplication we are doing. If you remember the some 12th standard mathematics, matrix multiplication is nothing but multiplication of row into column. Now see here, this is x double dash, and here suppose this minus k by m x, and here x is there. Hence obviously here the first term should be minus k by m. Okay, because if you multiply this minus k by m to x, then this term comes. We have to we have to bring this complete statement here in this matrix in the form of matrix. Okay, if you get some logic, then you can easily make this kind of matrix. Now just here x dash equation, x dash x double dash, this we know. This is 2 by 2 matrix, then x double x dash plus 2 by 2 by 1 matrix, matrix B. Matrix B is 2 by 1 matrix. Okay, then f of t. Now see here, we have to complete this equation. X double dash minus k by m x, minus k by m x. Then again minus b by m x dash is there. Hence here minus b by m will come. Okay. Now just to see the last second row only, plus f of t is term here, means obviously this is 1 by m, means here 1 by m will come. Okay, here 1 by m will come. In this way this second row is completed. Now here there is no x dash term we are given in the problem. Hence x dash is equal to x dash. In this way, like this you can write for x dash. X dash is equal to x dash. This is x dash, means here on the right side part only x dash should come. Now see here x dash is here. Now here and if you are multiplying the matrix, means if you multiply x by 0, it will be 0, and 1 by x dash, it will be x dash. His x dash, this x dash is equal to x dash will come, plus this is 0 into f of t, means 0 will come, means x dash is equal to x dash will come. Okay, means here the first term will be 0, second term will be 1. Okay, getting it. Now next, A matrix is over, B matrix is over. Now C x plus D, C and D we have to find out. Now here for C and D matrix, now see what is mentioned here. If there is only one f of t term and no derivative term, this you have to remember. Only one f of t term is there and no derivative term of f of t, then C will become 1 0. The matrix C will become 1 0 and D equal to 0. Okay, this way you have to remember. When there is only one term of f of t and no derivative term of f of t, then c will be 1 0 and d will be 0. Remember like this. Okay? 0 and and in this way y is equal to 1 0 y 1 0 and x is nothing but x dash 0 into f of t. Means after solving this becomes y is equal to x. Y is equal to y is equal to x. Y is equal to x. Okay. Okay. So in this way you have found out A, B, C, D. Okay. Now coding. Now this is the coding of MATLAB. Now first two statements are clear all clear screen. Okay. Then uh, m- mass is equal to 3 kg is given. Don't write down the units. K is equal to 800. B is equal to 20 semicolon. Force is again force value is given 12. Acceleration value is 0. If you want 4 and velocity value 0.5. If you want you can keep this or you can remove, no problem. And see first you have to write down A is equal to 0 1 A matrix 0 1 semicolon minus K by M minus B by M. For B matrix 0 1 by M and C 1 0 D 0. And for state is equation model you have to these are the something terms you have to remember. SYS is equal to SS ABCD semicolon. Numerator and denominator. N stands for numerator, D stands for denominator. Then SS state, state space transfer function of second degree equation. Okay, ABCD SS 2F. SYS is equal to now this line is used to find out the transfer function. This line is used to find out the transfer function. Line is used to find the transfer function, and we have to find the time constant, that is nothing but square root of m by k. X value we have to find out. Then y we have v square by 2a we have find out, and from this y we have found out the another force, and for this there is one equation. And this last statement step SYS is used to find the graph. This kind of graph, if you want to find step response, for step response you have to just write step SYS at the end of the program and you will get the state response curve. See, initially uh, this is the rise time is less, somewhat overshoot it is showing. Then the it is means it is getting ideal curve. Means it is no deviation is there, no oscillation is there. All oscillations are damped here. Okay, initially there is somewhat oscillations are there, sudden oscillation is there. It is called sudden oscillation, and slowly the amplitude of vibration is reducing, and and it becomes normal. Okay, after 1 second you can say 1 or 1.4 seconds, this equation becomes normal. Okay, now just you have to this coding I have shown you. Just if you go to the MATLAB, if you go to the MATLAB and copy this code. Already I have code is there with me. I will just show you. I will just copy the statement. Now what you have to do in the while writing the practical, theory part I have given, I will give you word file is there. These calculations you have to do. This calculation part you have to do with your own handwriting. Okay. Then you have to the whatever this code is there, you have to take the screenshot of this code, screenshot of this code, and screenshot of this response. Okay. Sorry. MATLAB is opening. This much is for your syllabus. You should know how to transfer function by using the MATLAB code. Okay. These are some ways. Here, same code is here for experiment number 6. Clear all CNC. I will remove this statement. Okay. Same code is there. Whatever code here, that same code is typed here, and just you have to save and run. Change folder and see here. Suddenly, output we are getting. Now see n what we have made statement in code. This is the output statement. Why this way it is showing, because here this is the output. This is the output. So here n is equal to is numerator. N is the numerator. This statement used to show the value of n and d. Okay. This statement is used to show the value of n. N is 0.000.033. Why? Because here, okay, because this numerator is having only one term, that is constant term, in 0.3333. Okay. Then denominator 1 6.6 to 66. Okay, 1 6.6 to 66. Okay. Then here this is the transfer function, SYS transfer function ND. Okay, in the numerator and denominator s square 6.6 is 260. Okay, then this time constant and distance and all, this is all this found out 0.612, 0.015, 0.031 and P47. Okay, here 47P 0.0612, 0.015. Okay, and okay, oh, and this is used to show the step and the pattern of the curve. Okay, is what you have to do in the theory part I have given. You have to just print out, attach the printout, calculation part right, and this is the your task. This screenshot and this screenshot you have to attach, and this practical will be over. Okay, in this way we will we have completed this experiment, and very simple experiment. You should take some idea what is the transfer function, what is the state space equation model, and for that this practical is there, and how to find out the step response. This much is sufficient from the practical point of view. And in the step response, see, you should able to tell initially there is more sinusoidal curve having more amplitude, means more oscillations are there. Sudden, this is the rise time is less. Sudden oscillation, then oscillations are damped because we have used the damping system here. Okay, remember spring mass damper system. Okay, spring is there because of the spring oscillations are there, but we have used the damper. Hence, that see amplitude is reducing, means the damper comes into picture here for this part, and after that there is a normal operation is performing this system. Okay, this smooth curve. This much you should know. Okay, now we will stop here. We stop the meeting.